Hello, this is Dr. Hassan with Innovate, and this is presentation number 8, Magic Square. This is a disclaimer for you to read. Magic Square, what's a magic square? A magic square is an n by n square array of numbers, where n could be add, like 3 by 3 squared, or 5 by 5 squared, 7 by 7, or 9 by 9. Or n could be even, which is 2 by 2, or 4 by 4, or 6 by 6, or 8 by 8 square, and so on and so forth. In magic square, the sum of all the numbers in each row, each column, and both diagonals is the same, is constant. This constant sum is called the magic sum, magic constant, m. Now, we can use any sequence of number, regular or irregular, but if we use a regular sequence of positive number, such as 1, 2, which is 1 plus 1, 2, 2 plus 1, 3, 4, 3 plus 1, 4, and so on and so forth, m, which is the magic sum, will be n times n squared plus 1 divided by 2. So if n is 3 or 3 by 3 matrix, m will be 15. If n is 5, m will be 65. Just evaluate this equation. For n is 3, we will have n squared, which is 9 plus 1, 10 times 3, 30, divided by 2 is 15, and so on and so forth. But this equation is true only for this sequence of numbers, if we use these numbers 1, 2, 3, 4, 5. Also, we can find out that the starting number for any m, for instance, sometimes you find people will ask, I need the sum, the magic sum is equals to 0, for instance, or equals to 1, or equals to 10, or equals to 20. So at that time, you will use this sequence y, comma y plus 1, comma y plus 2, comma y plus 3, and y could be integer or could be a non-integer number, could have really a fraction. Okay, now the value of y that you start with will be m minus 12 divided by 3. m minus 12, between parentheses, divided by 3. So for n is 0, you'll have y, which is minus 12 over 3, which is equal to minus 4. I will show you how we get this equation, y m minus 12 divided by 3. Hence, if we need m to be 0, then y minus 4, so the sequence of number we must use minus 4, minus 3, minus 2, minus 1, 0. Now, if m is 1, for instance, if we need m1, not 0, will be 1 minus 12, which is minus 11 divided by 3. So this will be a fractional number, okay? So the number does not have to be integer. You can have any numbers. The first number y, again, may be an integer or a non-integer number. Now let's look at the 3 by 3 square. 3 by 3 magic square is, we start actually, it looks like this. 8, 1, 6, the first row, the second row 3, 5, 7, and they will add up to 15. 4, 9, 2, they will add up to 15. 3, 5, 7, they will add the diagonal 8 plus 5, 13 plus 2, 15. This diagonal 6 plus 5, 11 plus 4, 15. And this column 6 plus 7, 13 plus 2, 15. 1 plus 5, 6 plus 9, 15. And 8 plus 3 plus 4, 15. So the sum actually of every row, every column, and every diagonal constant and is equals to 15. And I've showed you the equation y is 15 because we started with the sequence 1, 2, 3, 4, 5. Okay. Now how we come with the magic square, how we develop the magic square, and this is how we build the magic square. We start with the first number. Always we start with the square on the top center. So the center top square right here, we start with number 1. And we imagine there is an imaginary ball leaving the square by 45 degrees upward. So the ball leaving the square by 45 degrees. Now this ball will look actually for an empty square to reside in. Okay? So if you look at the ball, that horizontally has nowhere. There's no square. There's no square here. There's no square. So the ball will fall down all the way to the empty square, and the next number will be 2. So 1 here, and the ball actually left by 45 degrees and resided in the next square right here. So this will be number 2. Now once I have 2 here, the ball, the imaginary ball, will leave also by 45 degree, plus 45 degree, upward. Now, the ball vertically will get lost. There's no square here. So the ball will go horizontally to this empty square, and 3 will be here. So we get 1, 2, and 3. So the ball now here, and this is the number 3 will be here. Now again, the ball is leaving by 45 degree. There's a number here. There's a collision. Once there's a collision, so we'll take the next square, the square below. So 3, the square below, so 4 will come here. So in case of collision, we'll go to the empty square downward, or below, or beneath 3. So this will be. Now the ball will leave here, so this will be 5. The square will be 5. And the ball again will leave in 45 degrees, and this will be 6. This will be 6. So we'll come here. So we are in 6. So there's a collision here, we said. So the ball came here, 4, 5, 6. Now the ball will leave from 6. Now horizontally, the ball will be lost. There is no empty square. Vertically, there is no square. So we take the square beneath. So in case of collision, and in case of the ball will be lost because there is no horizontal or vertical square, we take the square below. So the ball will reside here. This is the empty square. So here 7. The ball again will leave with 45 degrees. Okay, there is no vertical square, but there is a square, an empty square. So all the way the ball comes down to 8 here. Now, again, the ball will leave in 45 degrees, positive 45 degrees. There is no square on the horizontal side, so the ball will fall all the way down to the empty square, so 9 will fall up right here in this square. So we finish the 3 by 3 square. With the same method, we can do the 5 by 5, 7 by 7, any size, or an odd n by n magic square with odd number, odd value of n. So 3 by 3 magic square. Once we finish the magic square here, 3 by 3 magic square, we will look at a magic square, just we said, with if we are given m, a specific m value like 0, we go to the equation for y, which is m minus 12 over 3. So when we say minus 12 over 3, we will start with minus 4. So I will start this square with minus 4. The ball is leaving. I'll go down, reside minus 3. The ball is leaving with 45 degrees. I'll go horizontally, so this is minus 2. There's a collision, so minus 1, then 0, then 1. We are adding 1, 1 to every number. Then ball here will be lost vertically and horizontally when it leaves, so we'll go down beneath. And the ball will leave, so we'll reside right here at 3. Then we'll leave and we'll reside here at 4. So here the sum will be 0 in every row, in every column, in every diagonal. Now also we can use any irregular sequence like all odd numbers, 1, 3, 5, or all even numbers. So if I start with 0, 0, 2, 4, 6, 8, 10, I'm adding 2 to even numbers, then 12, then 14, then 16. So they will add to 24. Okay, and this is a super easy, very nice, very recreational square. And now the equation for m minus 12 for the value of y does not work on this square, on this irregular sequence. The equation is valid for for how we develop this equation. The equation is valid for the sequence 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now the question is to ask how we develop the equation for, if we assume that this is y, okay, so this is y plus 5, and this will be y plus 7. So y plus 5 plus y plus 7, you'll get 3y plus 12 will be equal to m, or m will be, or y will be equal to m minus 12 over 3. So it came from this equation, so simple equation, and it works for the sequence y plus 1, y plus 2, and so on and so forth. So again, we were able to show you the square, how we build the square, how we have regular sequence or irregular sequence, how we have the square for the specific value of a given m, which is the magic sum, and we can build any square with odd numbers. Now, will be the end of this lecture. I thank you so much. Sincerely, Dr. Hassan.